Welcome back to this tutorial about building a linked list in Java. In this video we're going to go over how to implement the add methods of the list. So we'll take a look at the Java doc for these two add methods. The first one is add, and it takes in one parameter, which is an element to add to the end of the list, and it returns a boolean, which is always true. And so it just appends the specified element to the end of the list. So let's try to implement this now. I'm going to go back into my IDE, and the first thing I'm actually going to do is edit my node class here, because in our previous video I actually never added in a constructor. So I'm going to add in a constructor now that takes a data and a next node and constructs an initial node using those initial values. So that'll be this dot data equals data, and this dot next equals next. Oops, this is supposed to say next here. Okay, now that we've got that, we're ready to go implement our add method. So let's find it here. Here it is. So we have public boolean add, and it takes in one parameter. We know the Java doc said that it always returns true, so for one thing we'll make this return true. And now we'll add the logic for actually adding the node into the list. So the way I'm going to do that is there's two different cases that we have to worry about here. First is if the list is empty, so I'm going to call the isEmpty method. If it is empty, then all we have to do is set the head to be a new node using our constructor that we just made with the element with the data e and the next node as null, because there is no next node since this is going to be the only node in the list. And then also we're going to want our tail to be equal to our head. That way we have both our tail and our head set to this same node. Since there's only one node, both our tail and our head are set to that same node. And then we have another condition here. If it's not empty, then all we're going to have to do is add it after the tail node in the list. So what we're going to do for that is tail dot set next. So this will be the next node after the tail. Currently the tail's next is set to null because it's the end of the list, but now we're going to add a new node at the end of the list, which will be have the data e, and it will point to null since this will be our new tail node. And then we're going to have to set our tail to be the node after what we currently have set as the tail. And so that should do it for that case. And then we also just have to remember to increment our current size of our list, just like that. And that should be good for our add method that adds at the end of the list. Now let's go on to our other add method, which is right here. This one, let's find the documentation for it. Add, it returns, it has a void return type, and it takes two arguments. One is the index at which the specified element is to be inserted, and the other one is the actual element to be inserted. And it inserts the specified element at the specified position in the list, and then it shifts over any element currently at that position over. So let's do that. And then there's also another special exception here if the index is out of range. So if the index is negative, or if the index is greater than the size, then we're going to throw this index out of bounds exception. So let's deal with that index out of bounds exception first. It says if the index is less than 0 or the index is greater than size. So let's go back here and we'll say if the index is less than 0 or the index is I is greater than size, then what we're going to want to do is throw new index out of bounds exception. Okay, now we've got that case out of the way. Now how about the case of adding to the end of the list? We've already implemented our other add method that adds to the end of the list, so we can utilize that here. We're going to say if the I equals the size, that means we're adding at the very end because there's no element currently at index of the size of the list. The last element's currently at size -1. So at size would be at the very end of the list. So if the index equals the size, then what we're going to do is just call our other add method and pass in E, and that will successfully add to the end of the list. This will also take care of the case where the list is empty and I is 0. So if the size is 0 and I is 0, then this will just be adding the one element to the empty list. Okay, and then after we do that, we're just going to return because we have nothing left to do after that. Now, how about the case where we're adding at the very beginning of the list? So if I equals 0, we're adding to the very beginning of the list. We know that the list isn't empty because that would have already been taken care of by this case. So this is adding to the beginning of a list that already has elements in it. So what we're going to do for this case is we have to set our head equal to a new node which contains the element E, and it has a pointer to the next node, which is our current head node. The current head node is going to now be the second node in the list, so our new head node is going to point at the current head node, just like that. And that should do it for that. And then our last case here is what if we're adding anywhere else in the list, not at the very beginning, not at the end, but somewhere in the middle. This is the trickiest case because we're going to have to figure out where in the middle this node goes. So what I'm going to do here is we are going to have to loop through up until the current node in the list. So I'm going to use a j as my index variable in this loop. And we're going to loop up to I, which is the position that we want to add at. And then I'm going to do j++, incrementing by 1 each time. And what we actually want to do in here is find the node at which we are adding. So what I'm going to do for that is we'll make a node here called current, and we'll start that at head, and then each time we go through this loop we'll set current equals current dot get next. That way each time we'll be advancing current to the next node, and by the time the loop finishes, current will be the actual node at the index where we want to put this new node. But actually, if you think about it, we don't actually need the node at the index that we're trying to add. We want the node before that because we have to change the next pointer of the node before that. So what I'm going to do for that is change this instead to I-1. So now, after this for loop runs, we'll know that current is now the node before the index where we want to add. Okay, so now what we have to do is we actually have to add it. So what we want is current dot set next. We want the next node after current, instead of what it's currently pointing to, we want it to be a new node which has the data E, and its next pointer is going to be whatever current's next pointer is set to before we overwrite it right here. So that's going to be current dot get next. So this helps us to insert a node right in that spot where we want it. Okay, so that should be good for adding that node in there, because now we've got current.setNext pointing to our new node, and our new node is pointing to what current used to point to. So that effectively adds that node right in the middle of the list there. Okay, so then after that, we're going to have to, outside of this if statement, I'm going to do current size plus to increment the size, and that'll increment the size for both of these cases here. We don't want to increment the size for this case because the add method that we already have increments the size for that case. So that's why we have this return here. Okay, and so after we've incremented the size there, that should be good for the add method.